is just a dot over here, right? And this is the dot represents your fx. Okay, your fx, which is it is coming towards you, right? So because if you look over here, it's the head of the arrow is coming towards you. Okay. So at the top, point A, right? Moment is equal to 0, right? X is not equal to 0 because the structure can go what? Left and right. Okay. The structure for this case can go what? Left and right. So when you look at this is as good as what? This is as good as free. Okay. So from the member YZ, okay, from by looking at the member YZ. So for this case, one end is fixed and the other is free. Okay. So if we look at over here, one end is fixed and the other one is free. So what we have here, right, is this. One end is fixed, the other one end is free. So for this, when that's the case, LE is equal to 2L. Okay. So LE is equal to 2L for this case. So now when we do this, right? So we are going to calculate our PCR, our critical load. Okay, so we are going to calculate our PCR based on what? On the, I'm going to put bracket X, Y plane. Okay, we're going to put our PCR. So this is equal to pi squared EI ZZ over what? Over LE squared. So IZZ is equal to IXX also because it is what? Cylindrical. So the formula is pi over 4 multiplied by R power 4. Okay. So pi over 4. The radius is equal to what? The radius is equal the diameter. We are given the diameter. Diameter is 50. So am I right? Diameter. Let me read. Diameter is 50, so it's 25. Okay. So for this case, this is 0.025. So 0.025 power 4 times by shift pi 0.025 4 times by shift pi divided by 4. This is 306.796 times 10 to the power minus 9 meter 4. Okay. So for this case, our PCR on the XY plane, or about
Eugene, is this always the formula for second moment of area?
this is for a round for a rod.
Okay.
Okay. So this is equal to pi squared 200 times 10 to the power 9. IZZ or IX has the same value. I will provide you with this formula. Okay, so this formula will be given, don't worry. So our equivalent length LE is equal to what? L So the length given to us is 4 meters. Okay, so 4 squared. So this will be equal to 5 squared times by 200 power 9 times by 306.796 power minus 9 divided by 4 divided by 4. You get 37.849 times 10 to the power 3 Newton. Okay, let me do again. 5 squared times by 200 power 9 times 306.796 power minus 9 divided by 4 divided by 4. Yep. Okay. So this is for the critical load at the XY plane. Okay. Then the next one, we're going to calculate the PCR. And the PCR we're going to consider is your YZ plane. Okay. So for this case, your PCR or PCR, let me write properly. So we have our PCR. Wait, what am I doing? PCR on this plane is known as YZ plane. So the formula is pi squared E now is IXX over LE squared. Okay. So this is equal to pi squared. Young's modulus is 200 times 10 to the power 9. IXX and IZZ is going to be the same because it is a rod. And then you divide by your LE. So this is 2 multiplied by the length 4 and the whole thing squared. Okay. Pi squared, that's by 200 power 9, that's 306.796 power minus 9, divided by 8, divided by 8. So the load that it can carry now is 9.463 or 462 times 10 to the power 3 Newton. I'll do it again. Yep, 9.462 times 10 to the power 3. Okay. So the structure will buckle. Okay, so we have to select PCR about the YZ plane. And this is equal to 9.462 times 10 to the power 3 Newton. Okay. And I think a key indicator, a lot of times students make mistake, right? Is due to the fact of this, okay? Is due to the fact that it's due to the fact that the LE is different, okay, between the two axes, right? So if you look at the XY plane, both are pin, right? For this case, right, because it can move left and right, right? It has a motion about left and right, okay? So it's as good as free. So that's why LE is equal to L. Okay, so it's going to buckle by the YZ plane, okay? So from here, we know our P critical, and our P critical for this case, right? So our P critical is also equal to our FAB. Okay. So we have found a relationship of our FAB, right? Which is equal to 2.732 FAC. So this is equal. So we're going to, so I'm going to call this equation number 4. Right? So we're going to substitute equation number, can't remember now, number 3 into equation number 4, right? Because when we calculate PCR, right, coming back to this diagram, PCR is acting in this direction, right? Whether is it about the which plane you look at, right? Because of how it's fixed is differently. So the PCR for the YZ plane is basically the axial load being applied. Okay, axial load being applied along the FZ plane and XY plane are the same axial load. Okay, so let me highlight that again. So if we view this in the Y plane, right? If we view it this way, the critical load is going to apply at the, let me draw this properly. Okay. So this is about the XY plane, right? So this is our point A, and this is our point B. Right? So what we see over here, this direction, right? This is going to be our applied load, right? And then if we view it, so this is our P critical. And then if we're going to view it in the YZ plane, okay, this is also our PCR. And this is also our PCR. Right? So we have selected the PCR to be equal to what? 9.462. Okay, times 10 to the power 3 Newton. So in the XY plane, right, applied along the axis is also what? PCR is also equal to what? 9.462 times 10 to the power 3. Okay. So from here, that's why we can formulate this expression over here. Okay, we select it to be 9.462. So 9.462 or PCR is equal to FAB, right? But the 9.462, sorry, we still cannot we cannot use this. Sorry, I should not. Can you all get rid of this expression over here? My apology, because there's a factor of safety. So factor of safety, right? Factor of safety is equal to PCR over our P. Okay. So P is equal to PCR divided by our factor of safety. So now this is 9.462 times 10 to the power 3 divided by our factor of safety, which is equal to what? Can't remember now. Factor of safety, which is equal to 2. Okay. So this is equal to 9.462 power 3 divided by 2. It's equal to 4.731 times 10 to the power 3 Newton. Okay. Then we're going to substitute, we're going to use P is equal to what? We have this expression over here, P is equal to FAB. Okay. P is equal to FAB. And this will be equal to 2.732 FAC. So therefore, FAC is equal to 4.731. Let me write on the next page, okay? So this will be equal to
I'm sorry,
4.73.
Eugene, isn't it meant to be PCR that is equals to FAB?
Say it again.
Is it meant to be PCR equals to FAB? That's what you wrote
PCR.
before.
No, because I forgot there's a factor of safety.
Oh,
So,
okay.
okay, there's a factor of safety over here. So all this, the 9.462, okay? So once we have all this, these are all your FAB. So the FAB, regardless of the plane you look at, the FAB is going to be the same. Okay, so all these are your FAB. I forgot about the factor of safety, that's why the confusion. Okay. So now we have our FAB is 2.732 FAC. Okay, so FAB. So P so FAC is equal to our P, which is equal to 4.731 times 10 to the power 3. Then we have to divide by 2.732. So 4.731. So this is now 4.731 power 3 divided by 2.732. So now this is equal to 1.731 or 732 times 10 to the power 3 Newton. Okay. So therefore, so now where are we now? Okay, so if we were to look at the rope, right? So we calculated that this rope, when pulling down, okay, the allowable load is 1.732 times 10 to the power 3 Newton. Just pulling down. If you pull down higher, it will buckling will occur on the so this is X, buckling will occur on the Z plane. Okay, so therefore the mass allowable will be equal to 1.732 times 10 to the power 3 divided by 9.81. Okay, so 1.732 is equal to 176.6 kilograms. Okay. So it's important. Okay, this is important. Okay, that's why any structure that you do, you have to look at two possibility of buckling. Okay, and then the critical, if we were to calculate the critical load, is P critical divided by the area. The critical load, so our P critical we use is what? Is equal to 9.462. Divide by the cross-sectional area, so pi multiplied by 0.025 squared. Is equal to 4.819 times 10 to the power 6 Pascal in compression. Let me do it again. .19, okay, in compression. So this is less than the stress yield, and the stress yield is equal to, let me see what's our stress yield. I can't remember now. 703 times 10 to the power 6, which is less than 703 times 10 to the power 6 Pascal. So the structure will not yield. Okay. Sorry, the problem went longer than expected. Okay. Let's take a 5 minutes break. We come back again in 5 minutes.